Now let's continue our tour through the data types in this second part. And let's continue with the exact numerics, and let's look at the money data type. Now when I need to store money data types in my database, notice I can use the money type, and it goes from negative whatever that number is. Let's see, that's going to be billions, trillions, negative 922 trillion to positive 922 trillion. So unless you need to manipulate numbers larger than that, the money data type should take care of you. Do be aware it's going to store the data in 8 bytes of memory, somewhat expensive. Then there's a small money data type that allow you to store numbers from negative 214,700 plus to positive 214,748 plus. Notice that one only takes 4 bytes of memory. That's our money types. Now approximate numerics. Let me get both of these up here. You have float and real. Now, approximate numerics use a floating decimal point. Now, these things are popular and they're convenient, but they're not precise. So be aware that you should not use these in financial calculations, medical, scientific calculations, where accuracy is utmost importance, because you will get rounding errors and changes in your data, slight ones, but changes nonetheless. So notice you can use float that gives you up to 8 bytes. A lot larger numbers can be used. And I'm not going to convert from the exponential notation here. You can do that. Or the real, it only uses 4 bytes, stores less. So you have to decide what you want to use. Now the date types are very popular. They're used quite often in database programming. The first date data type that we'll talk about is date time. Now date time will store dates, look at this, from January 1st, 1753 through December 31st, 1999. Now that's a huge span of time. It takes 2 4-byte integers, or 8 bytes total data, total space to record this. But here's what will usually cause most people to have to use date time. Most of our apps don't use date ranges from 1753 to 9999. And notice that's not 1999, but that is the year 9999. But it will store any date to within 3.3 milliseconds of accuracy. So if you need to know exactly when something happened, you can use date time to store that to within 3.3 milliseconds of accuracy. Small date time is probably more realistic in most situations. This allows you to store dates from January 1st, 1900 through June 6, 2079. Now, if you need to forecast past 2079, you'll have to go to the date time. But notice this one uses 2 2-byte integers, or 4 bytes, and it gives you up to 1 minute of accuracy as far as when you actually can show the actual date and time stamp. So sometimes this milliseconds accuracy will force you into date time. Character strings. This is real interesting. Let me get them both up here. We have character data and variable character data. Now you'll hear this called char and varchar in the real world. Character data says you can store from 1 to 8,000 bytes, and you will always see this notated as CHAR, and then in parentheses here a number. So if I put char 20 in parentheses, it means store 20 characters or 20 bytes of data. Now, if I only store 5 characters, it will store those 5 characters and 15 bytes of empty data. You don't want to store empty data in your database, obviously. SQL has to search through it and manipulate that data later. It's not efficient. There are places, states, for example, we know there's only 2 characters, so we set a state data type as char2 for a state column. Varchar does just the opposite. If we tell varchar 20, it stores up to 20 bytes, but if we only store 5 characters, it stores those 5 characters and returns the other 15 back to the operating system or back to the database. So it doesn't use or store empty data or empty memory. Text data types can store up to over 2 billion characters. This is going to be removed in future versions. Microsoft's giving you the heads up. Stop programming to this. Use varchar and var binary max for this, and also nvarchar max. For Unicode, keep in mind with Unicode, we simply doubled the size of our character set to let us store more characters. This gives us the ability with just regular character sets. We can only store the standard English language alphabet plus some Spanish language alphabet and a few others. With Unicode, since we doubled it, we more than doubled it, actually doubled the number of bytes that store it, we lost 4,000 units here on the characters we can store, but we have twice as many characters we can store. And as a matter of fact, we can represent most of the known languages in the world with these character sets. So we have nchar and nvarchar. in text, same deal as before. This is going to go away. Then we have binary types. We have the binary data type. This stores binary data either in a fixed length or a variable length, just like char and varchar. And then we have the data types that have gotten most of the press, and that is the table data type, where I can actually store result sets in a table variable or a table data type. And then the XML data type that I can store XML data in. So that's a rough, real fast run through on these data types. You need to know that they're out there, and you need to become aware of how to use these efficiently. And again, I would strongly urge you to go out to the documentation and read up on these and make sure that you're using the appropriate ones in the most efficient manner.